Welcome, everyone. We'll give people just a few seconds to get joined into the webinar here. So we'll kick it off here in about 1 minute. All right. Good afternoon and good evening, or maybe good morning to some of you all. Welcome to our webinar today, our Sphero session on coding and engineering with Rover Plus. We're going to go ahead and get started with a little bit of housekeeping items, just to kind of keep things moving. If you see a little bit of some blocks on the screen, we'll try and get those cleared up here shortly. Today's webinar, we're going to go for about 30 to 40 minutes with some question and answer at the end. So stay posted to this webinar to keep track of what's happening and to ask some questions and to get your questions answered at the end. This webinar will be recorded. So at the end of the session, you will be able to have these slides sent to you. In a couple of days, there'll be a follow-up. Also, if you notice in the chat box, there is an option, there's a drop-down menu that says you can set the chat to everyone. So if it's only allowing to send to panelists, let us know and we'll try and get that figured out. And as we're working through today's Sphero session, there is a question and answer section. So please feel free to drop questions in the Q&A section. We have several moderators who are not going to be presenting live to you today, but they are here to help answer questions as we go through the webinar as well. And if you stay with us through to the very end, guess what? This could be your lucky day. We are going to have a Rover Plus giveaway at the very end. So our agenda today, we're going to kind of do a little bit of an introduction between Brad and I. We're going to introduce you to Sphero Rover Plus, and then we're going to start talking about classroom implementation. So there's a few different categories of classroom implementation that we're planning on talking about and sharing today. We'll talk through some best practices and some really neat ideas of what you can do with Rover Plus, depending on your classroom and what your setting is. And then we also have some great resources for you to be able to follow up with at the very end. We'll finish with question and answer and our giveaway. So without further ado, let me introduce myself. My name is Nate. I am a product manager at Sphero. I've been with Sphero now about 4 years. I was a public ed teacher. Before that, I taught 6 years of language arts, and then I transitioned into instructional technology and into STEM and computer science teaching. So it's been a lot of fun to come over to Sphero and kind of infuse some of that education focus into all of the products that we do. I started in professional development and training, and now I work on our product team to make sure that all of our products are really designed with classes and teachers in mind to make sure that our kids are having the best day of school. And then I want to also introduce Brad. I'll let him unmute and kind of introduce himself as well.
All right, thanks, Nate. My name is Brad Fessler. I'm a professional development and content manager here at Sphero. I worked in public education for 15 years, teaching technology and engineering. I also worked in higher ed for 4 years, teaching CAD concepts. So both full-time, part-time in education, and I also am a national teacher effectiveness coach for ITEA. They have a curriculum called Engineering by Design. So I'm a coach and an author there. Thanks, Nate.
Awesome, Brad. It's exciting to be here. Brad brings a great wealth of expertise, especially on some of the higher end side of the content that we do. In professional development, he does a fantastic job. So let's introduce Rover Plus today with you. I kind of like to introduce Rover Plus first with just a high level view of what Rover Plus is and where it came from. So back in 2019, Sphero launched our original Rover robot. So it's been about 3.5 years since we launched that first robot. Now, a few years ago, we realized that some of the things that we had put into the original Rover didn't quite fit classroom use. So we had an opportunity to make some improvements and to really optimize Rover Plus for the classroom. So when you think about the original Rover versus the Rover Plus, everything that you could have done with the original Rover can also be done with the Rover Plus. But a couple things that we've done to make it unique and better is that we've improved the gearbox. So what does this mean for you in the classroom? The improved gearbox does two really big things for Rover Plus. The first thing that it does is it actually adjusts the speed. So the new Rover Plus is actually slower. It slows down in the classroom, which allows it to be able to maneuver and work in a more controlled space as opposed to the previous Rover, which was really zippy. So Rover Plus, we've improved that gearbox specifically so it's easier to work with in the classroom. But the second piece is, as Brad's going to kind of share and do some more exploration with later, is it increases the actual payload that Rover Plus has. And this allows you to do more inventions and doing things on top of it, which presents some really, really neat experiences. The other thing that's really not unique, but new and better about the Rover Plus is we took what we learned from the implementation of a color sensor in Indy and took some of that same engineering and applied it to Rover Plus. So we improved the color sensor so that we make sure that when kids are using the color sensor as part of their event blocks in the programming environment, they have the ability to be more precise and accurate with their programming. Now on this slide, one of the things that I like to highlight here is that Rover Plus, it kind of is nestling a little bit as like that middle school to high school age range, or like 7th to 12th grade. Could think about it maybe about 12 or 13 to 18-year-olds if you're thinking about it outside of the US market in the different grade levels. But one of the things I like to highlight about Rover Plus specifically is you'll notice that line above that, that chart there has Bolt. Out of the box, Rover Plus has the exact same programming experience as a Bolt does. So even if you have Rover Plus with younger grades, they'll be able to do almost all of the programming that they can do with Bolt with the Rover Plus. So it's using the Sphero EDU app, it's programming with blocks, or it's programming with our draw canvas, or as you get older and want to explore more with JavaScript, that's all available for you as well. So that's the high level view. That's the big things about it. Now, let's talk about some of the guts. I like to call it the guts of the robot. So we've got a Rover Plus here. I'm going to use it a little bit. I know I'm displaying the slides, so you might have to look at the small little box to see some of the things I'm talking about here. But if we are to remove the cover plate from our Rover Plus, you can start to see the inside of the Rover and everything that's in there. So we have things like a 6-axis IMU, which is going to allow the Rover Plus to understand where it is in space and the relationship to its space. So it's going to have an X, Y, and Z axis being measured on the accelerometer, the gyroscope, and it can also use a distance calculation to figure out how far Rover Plus has traveled. It also has a color sensor. If you flip Rover Plus over onto the bottom, I call it its belly button. It's kind of on the bottom of the robot. And there's that little circle on the bottom. A couple white LEDs will shine when a program is started, which allows that color sensor on the bottom to be able to receive more information and more light so that it can sense a better accuracy of the color. There's also, it's gonna be hard to see if you don't have one in your hand, but there is a little channel at the top of the thing here that is an ambient light sensor. This allows Rover Plus to be able to read the light intensity of an environment and be able to have students use that as a programming condition. So if it gets dark, we could have the robot do something, or if it becomes brighter than a certain intensity, Rover Plus can do something. And the last thing I'm going to highlight, and if you look at the Rover Plus from the front, there's a little like smoky gray glass on the front, on the sides, and on the back. And that is where our infrared sensors live. So Rover Plus has the ability to send and receive infrared signals between itself and other Rover Pluses or other rovers or even Sphero Bolt. So you have the ability to do some modified swarm robotics. You could have some bolts following a Rover Plus across a classroom and things like that. Pretty cool things. But as I mentioned, that's the guts. That's all the fancy things that you can do with the Rover Plus. But just out of the box, you can just program it as is without thinking about anything else. You can drive with it. There's new drive commands in our Sphero EDU app that allows you to drive our Rover Plus and our rovers more accurately through more of like a remote control car style driving mode. As I kind of pointed out, you have the ability to pop off this cover plate and the mounting plate. And we also ship with the Rover Plus a developer plate. This developer plate, you'll notice, has a bunch of different holes, and it has a bunch of different slots where you can slide different types of screws and standoffs to be able to mount your own hardware onto the top of Rover Plus. And so I'm going to talk a little bit about what you can do there. I'm going to push this off so I can highlight the last piece here on Rover Plus. There is a little door that opens up to expose a USB port and a UART port. UART stands for Universal Asynchronous Receiving and Transmission. Allows you to connect a Raspberry Pi to it, send and receive data from the Raspberry Pi to the rover. The USB port is also power and data, so you can power and send information back and forth between like a microbit. And those pieces, that USB port, it supplies 5 volts, 2.1 amps. So it allows you to be able to power a Raspberry Pi and or your microbit inventions or your little bits inventions on top using that developer plate. Brad, I'm going to ask real quick, is there anything else I've missed about the guts of the Rover Plus? I guess I didn't talk about the battery. I should talk about the battery. That's another nice thing, right?
Sure.
All right, so real fast, I forgot to talk on this. The Rover Plus, on the side, there's a little door lock that you can open up, and it opens up to a channel where you can slide in the battery. The battery is charged by USB-C. There are little LED lights that you can see how full your battery is, and you can just slide that in there, and then you can lock up your battery door, and your Rover Plus is ready to go. When you power it on, you'll actually see the lights turn on. And once the lights are pulsing purple and blue, you'll be able to connect your rover to your programming device and get programming. The battery is really nice. It's our first robot that we've ever made that has a swappable battery, meaning you could buy an extra battery for your classroom. And the battery will last all day if you're just doing standard programming with it without building stuff on top. But as you get into some of the more engineering intense projects and things that you're pulling some of the power from the battery from that USB port, that's where you might see the battery life need to be extended or supplemented with additional batteries throughout the day. So that's a little bit about the nuts and bolts of Rover Plus. The one last thing I'm going to highlight, and I'm not going to talk too much about it right now because Brad will speak a little bit to some of the capabilities a little later. As I mentioned, out of the box, you can drive Rover Plus as is. You can program it as is. But if you want to start to go to the next level, we have a public SDK that's available. It's sdk.sphero.com, and it allows you to understand how the robot's working using Python. We also have an extension for Microsoft's MakeCode, so you can program a microbit using the MakeCode editor as well. There's a lot of really neat things. If you want to take full command of the Rover Plus, the Python's going to give you the most flexibility to be able to do any of that stuff. So The last thing I'll say is we don't sell any of the third-party development boards like a microbit or Raspberry Pi. Those are things that we're hoping that classrooms already have and that you'll be able to take advantage of with your students if you have some Rover Pluses in your classroom. So real fast, I'm gonna hand over a little bit of the slideshow here to Brad. He's gonna talk about some of the classroom implementation of Rover Plus and share a little bit about how you can get started right away out of the box with simple activities. And then as you go, as your students get more advanced, they can start to scale it up into some more complex ideas and concepts. So take it away, Brad.
All right, thanks, Nate. I appreciate the great introduction to Rover Plus. It is a pretty capable, amazing robot, especially when you start adding things onto it, which we'll talk about here in just a moment. So as Nate alluded to earlier, you can program Rover Plus straight out of the box, no need for third-party hardware or plugging in anything or complex setups or anything like that. You can simply charge up Rover's battery, slide the battery in there, lock the battery door, and download the Sphero EDU app and start driving and programming. There are 3 ways that you can program your Rover Plus. The first one is Draw Canvas, and Draw Canvas is really geared towards those elementary, maybe very beginner middle school students, but it's tailored for those younger students. It's not designed for your upper middle school and high school students. Draw Canvas is a great way to learn how to connect to the robot and get the robot moving just within a few minutes. It does not allow you to do a whole lot of precision things or allow you to do a lot of advanced coding, with the exception of moving the robot around. That's when we move into block coding. And the block coding allows you to utilize all the different sensors that are on board of Rover Plus. You can handle driving, you can handle communications, you can handle color, you can do all kinds of advanced coding concepts right in block programming. And that's where those late elementary into middle school and even beginner high school students usually like to get started and learn the basics of programming. As a teacher, when I was using Sphero robots in my own classroom and I was teaching advanced programming using different programs and things like that, different languages, I would use my Sphero robots to teach the concept so I could chunk the information of, hey, now we're learning this concept. We don't have to learn the syntax of the coding language at the same time. So we could learn the basics in code and block coding, and then jump over to text coding and apply that. And we're just learning instead of the concept and the syntax, we're just learning the syntax. The third way we can program Rover Plus right inside of the Sphero EDU app is our text canvas. And this text canvas uses JavaScript. So you can go through and you can type right in here in JavaScript. There's a cool little wiki that's built into the text canvas that you can go in and see all the different JavaScript codes that are specific, those functions that are specific to the Rover Plus. The cool part is if you're trying to transition from the block coding to the text coding, you can actually program something in block and then see what that looks like in JavaScript right inside of Sphero EDU. So this is a great way to get your students who are maybe in that transition phase from the block coding to the text coding, get them to start making those inferences of how all these work back and forth. So a lot of fun ways to just program right out of the box, don't have to add anything to it. Now, when you get your students to a point where, hey, it's time to go beyond the basics of programming and we want to start integrating other hardware, the first step to this is Little Bits. We have a product called the Little Bits Topper Kit, and that Topper Kit comes with a handful of bits that are specifically chosen to work with the Rover Plus. So these bits enable a lot more functionality, a lot more creativity into building on Rover Plus. So this gives that development platform now in that robotics field. You don't need any external battery source when you're using the Little Bits topper kit, because you can take that USB power bit and you can plug it right into Rover Plus's USB port. Rover Plus is more than capable of powering your Little Bits inventions that go on top of it. So your rover can act as the big battery and then get that Little Bits moving around your space, which is really, really cool. The other thing that's a whole lot of fun here is to use infrared communications from Rover to Little Bits. So Rover has the ability to send messages via infrared using the communications blocks or the commands in JavaScript. And Little Bits has a bit called the IR trigger. So looking at this slide, this particular sample circuit that's there, we have that USB power is powering our Little Bits, and then we have that remote trigger. That remote trigger allows us to use our Little Bit circuit like a switch, right? So we can send a command via infrared to turn on the Little Bit circuit using the trigger, and then tell it to stop communicating, and then it'll turn that off. You can also send a message and increment things like the count, the number bit, to keep a count of things. So if you're scoring a game or things like that, you can send a signal to it. You can do a lot of really cool things, and you'll see some other resources a little bit later in our presentation of ways you can implement the Little Bits to do a bunch of things. Here we have an example, the servo motor. You can attach like a T-pin to this and pop some water balloons or things like that. You know, put a marker on there and be able to draw and control when that's moving. So a lot of fun to go through that. So here's a sample of one of our inventions that go on there. This is a lifter. So this is using Little Bits and the servo, and we can see Rover drives up, grabs a hold of that ball, and then we send an IR signal to the Little Bits circuit, and it flips that ball up into the container that's sitting on top. And then we turn off our IR communications and the lifter goes back down. These 3D printed parts are all available for free on our Thingiverse channel, and we'll talk about that a little later in more detail. But if you're interested in that, quick, we'll leave this up here for just a moment. Scan that QR code, and it'll take you right to this particular invention in Thingiverse. Can all be easily 3D printed and ready to go. So
Hey,
this
Brad.
is just one. Yep, go ahead, Nate.
Oh, I was going to ask, with the Little Bits topper kit, that's obviously something that, but if someone has maybe like a Steam Plus set of Little Bits, or maybe they have like the Makerspace invention wall that they've got maybe in a Makerspace and they want to add a Rover Pluses, does it have to be the Rover topper kit, or can they use any of the other stuff?
No, that's a great question, Nate. No, if you have the Makerspace invention wall, you already have all the bits that you need to make this work. If you have the Steam Plus kit, you're missing one bit, and that's the IR trigger bit. So that remote trigger bit, which you can buy individual bits as well. So if you're just missing that one from the Steam Plus kit, you know, you can jump online and grab that. There's also other ways you can interact. You can use the proximity bit to measure a distance. That's a fun one. If you're doing the servo arm for a balloon popper, you can use that that sensor as well. All right, so on our next slide here, we're going to talk about microbit. So microbit is not a Sphero product, but we do support the integration of microbit with our Rover Plus. So the cool part about this is you can build microbit projects using MakeCode or even their Python editor in MakeCode, and then get those microbit projects moving physically by snapping them onto Rover. There's all kinds of attachments you can do. You can bolt them on. we have a 3D printed holder that snaps onto the microbit, so you can actually hold that on there. It's a free thing on Thingiverse again that you can print, get that microbit on there and moving. You can use MakeCode, which is block-based programming, or you can use MicroPython. So you can actually go through and do some of that Python coding. In either case, we have a custom rover extension to do that. So while I'm talking about that, you can see Nate has our video playing here. This is using the onboard thermometer that's on the microbit. And we're using a second microbit there as a remote control to change the target temperature. And rover's behavior is changing based on that target temperature. So when the target temperature and the measured temperature are the same, rover's going to turn green and just kind of hang out there and scroll some information. When it's too hot, rover's going to move in a pattern trying to cool down. And if it's cold, it's going to turn blue and sit there and wait for that temperature to warm up. So really cool kind of projects that you can put together there. All of these are done using our custom rover extension. So if you're using the MakeCode side of things, if you click on extensions and just type in the search bar RVR, you can load the custom rover extension. And what that will do is it'll give you access to movement commands. It'll give you access to the lights, as well as if the rover is awake or asleep. So those are all in there for you, ready to go. If you're going on the Python side, there is an extension also available for that, and it's at sdk.sphero.com. Here we can see in our second video, we're doing soil moisture testing, right? So our rover is driving to the different stations. It is moving a servo arm, taking those samples and recording that data with the microbit. So you can report that back. Again, we can do all the power can be derived from that USB port that's built into rover. So again, no need for an external battery when you're doing this. And the microbit will send data back and forth using that same USB connection as far as being able to move rover using that. The other thing that you can do with a microbit, we have a little bit that is called the microbit adapter. And you can actually use microbit to code and then use little bit sensors and output devices using MakeCode to integrate all of those systems together. So if you started with little bits and then went to microbit all on top of your rover, now you can combine them and work with all those, giving you tons of different options to work with. All right, and our next one is Raspberry Pi. So we've worked through some basic kinds of coding, whether it be draw, then block, then text coding in Sphero EDU. Then we went to our little bits to build onto our engineering portfolio here for ourselves, and then into microbit as we got a little more advanced. The Raspberry Pi is for your really excelling gung-ho students that are really into the robotics thing, they're really into programming and technology. This is not for your beginner students, okay? Totally doable, there's lots of support for it, but you don't want to start here. This is where you want to end up. So you can program using Python and JavaScript, right, with a Raspberry Pi. Our Rover Plus and the original rover were both designed with the Raspberry Pi 3B Plus in mind. If you have a newer Raspberry Pi, it may, depending on your build, it may be necessary to add an external power supply to the top of rover. The newer Raspberry Pis are a little more power hungry and can sometimes be reset by drawing too much current from the rover battery at one time. One way you can kind of mitigate this, if you're using motors and things like that, is to stagger start your motors, meaning, and if you're turning on two motors, start one, let it start for a second, then start the next one. It'll help reduce that current draw that can help you through there. Again, all of this is supported at sdk.sphero.com. There are direct instructions on how to get your Pi set up, how to be able to remote into that using terminal commands and SSH protocols. So you can remote control your Raspberry Pi and your Rover using that. And again, just a reminder, as Nate said earlier, your USB port for power can only draw 2.1 amps at 5 volts. So if you're drawing over that with your project, you need to look at an external power source as well. Also, one thing I forgot to mention is that UART port is there for data transfer as well as power and ground. So you can see in this example, we have a breadboard attached there, and there's all kinds of things attached. There's sensors on the front of Rover as well. And you can power and send data using those UART ports as well.
Hey, Brad, I was wondering if maybe you could speak a little bit too about like the actual like third-party hardware components, like where can I get them, or what exactly should I be looking for if maybe if I'm teaching a high school engineering class and I want to dabble with some of these things, like the Raspberry Pi, I have a couple of those, but maybe like the components, is there something that I should be paying attention to?
Yeah, absolutely. That's a great question. So there's tons of starter kits out there. You can find them on Amazon. You can find them places like SparkFun and other sites like that, where you can grab different kinds of sensors, outputs, motors, screens, even video camera, like webcam type setups, where now you can see remotely what is happening with Rover. So what you'll want to search for is like a Raspberry Pi starter kit or sensor kit. And you can do some web searches and find all kinds of things there. They do range in price depending on what you're looking for. You can find some relatively inexpensive ones in the like $30 range. And then you can find some that are rather pricey depending on what you want to do. The cool part is, you know, you can use sensors and output devices that are either 5 volts or 3.3 volts that can all change using the Raspberry Pi, or some other hardware to change your power, your voltages around for you. But that's a great question. Thanks, Nate.
Yeah, and I think it bears kind of piggybacking off of that and saying, when you get into the realm of playing with the SDK and you're going into more the open source electronics projects, it's a blessing and a curse in a lot of ways, because there is so much information out on the web that you can find. Libraries to be able to do some really fun projects and things like that. But it also requires you to kind of understand how all of the libraries for different sensors and components are going to interplay with the Rover Plus libraries. And so it's not one of those things that's just like a quick, I'm going to turn it on and it works. It takes a lot of debugging, and it's great for students who are at that higher end, who are looking to maybe go into more of the engineering background. But it also gives them a really good opportunity to understand, get repositories. It helps them to understand how they can look at API documentation and libraries and really understand some more of the detailed pieces of that.
Yeah, 100%, Nate. Definitely, it's not a starter place for students, but it is a development platform at this level. So you can start with just getting it moving and learning the Python side of things and how those libraries work and setting up a Raspberry Pi. And then you can go into full-on autonomous vehicle type setups and some really cool custom type things. Absolutely. It definitely spans a large portion there. All right. The next thing we have here is, this is our Rover Plus activity progression chart. So it starts with beginning block, so learning how to get Rover moving, using that color sensor, and then using the communications portion of Rover. So using those infrared communications to get Rover to talk to Rover, other rovers. You can get Rover to talk to little bits, and you can get Rover and Bolt to talk to one another as well, which is really cool. So you can send commands from Bolt to Rover. You can send commands from Rover to Bolt because they all work on that same infrared communication system. So you can really do some fun things with getting the different systems to work. So if you have the ability to work with multiple Sphero robots, this is a great way to intermix those and bring them together. Then, of course, as we move into our intermediate block programming, we're looking at loops and sensors and different speeds and colors. We start looking at those if-then conditionals, variables, and functions. So we're getting into those little more complex programming ideas that students should know moving forward. After that, then we start bringing in the third-party hardware, looking at little bits, and then moving into the microbit. And then if you want to go further, that's where the SDK comes in with Raspberry Pi. It is important to understand that you don't jump in at the top end of this unless your students have the experience and the background knowledge to do so. You want them to start in the block programming world and then move up unless they already had that at another level.
When you look at this progression chart, it just kind of makes you understand a little bit more about how Rover Plus is kind of like the jack of all trades of robots. Like you have the ability to just do basic computer science concepts. You're doing physical programming with a robot. It's a lot of fun, but then you can really adapt and build upon it and do some really neat things.
Yeah, it definitely shows the versatility of the robot. Now, we also have a lot of resources for Rover Plus. So I mentioned a few times we have a Thingiverse channel. There's a bunch of different things that are published on there on that Thingiverse channel. If you scan this QR code, you'll be able to pull up some of those things. I think some people are going to maybe throw some of these links in the chat for us so you can actually click on those links and have those resources handy for you. But on the Thingiverse channel, if you are a 3D print capable person, right? There's all kinds of things that are out there for you that are fun. A couple instances we see here. We have a microbit mount that bolts to the developer plate. We also have a bumper that snaps into the little bits grid that can go on there, and that allows you to put some different sensors on the front or back or sides of Rover as you go through. Really pretty cool. Again, Nate and I have both mentioned the Sphero SDK that's in there, and that works with both microbit and Raspberry Pi. I noticed a couple people in the chat were asking about Arduino. There is some information about Arduino in there, but that is no longer in development. So you can plug it in and give it a shot, but you may run into a couple little issues as you go through there. But check out the microbit and the Raspberry Pi resources in the SDK. We also have our Rover Plus resource page, which has all kinds of activities. It has our educator guide, which is our next one that's involved there. That educator guide has a bunch of activities that can take you from, I just got a Rover and this is the first time I'm programming with block programming, all the way up through doing some things with microbit and little bits. So a lot of cool activities built in there and ready to go. We also have a professional development course that will be coming very soon. It's called Rover Plus Fundamentals, and it takes you from block programming through the JavaScript into little bits, microbit, and even talks briefly about the Raspberry Pi and the SDK. It is a asynchronous training that you can go in there and do on your own time as you go through. Check some things out. There's some cool activities that are only available through the Rover Plus fundamentals that are in there. So it's cool to see some different kinds of activities as well. Nate,
Awesome.
any questions about the resources or comments about the resources out there?
There's a lot of people who are asking a lot about like programming in C or Arduino. So we've got those covered. Which is really good. So I'm going to just real quick kind of share the last couple few pieces and what you can do to equip your classroom, just to reiterate. If you are looking for some Rover Pluses, obviously there's a multi-pack that we sell specifically for the classroom use. It basically comes with 6 rovers, pluses, and you're going to have 6 of all the accessories that come with the Rover Plus. And then you'll also get an educator guide with it. The Rover Plus educator guide, as Brad mentioned, is available for free online as a PDF, but you can go ahead and purchase a nice print version of it as well from the website. Our Rover Plus battery is available on the website as well if you need to supplement your classroom with more batteries to keep your inventions powered throughout the day of programming. And last but not least, you have the Little Bits Rover Topper Kit, which Brad talked a lot about. I'm gonna real fast, I'm gonna answer one question really quick, which is how do you get the extension on MakeCode for Microsoft MakeCode? Did I type that in wrong? There we go. So when you are starting a project using MakeCode, there is a spot down at the bottom of the middle column here that says extensions. You can click on extensions, and up here you can search for the extension for Rover. So if you just type in RVR, you'll actually be met with the tile here that is the Rover SDK. And so you can load that. And now you'll actually notice that I have a whole new section of blocks available on MakeCode to be able to control the Sphero rover. And the nice thing about this using the MakeCode is I have the ability to do it all through my microbit. If I've got the Little Bits microbit adapter, I can use that to also control rover and the Little Bits inventions with the microbit. It's kind of like the interplay of all of the cool things.
Thanks,
Awesome.
Nate.
Yeah, I'm just going to take a quick look for any other questions that kind of have been popping up here. Here, Brad, I'm going to ask you this one just since it just came in a little bit a while. Can you use like microbit or Little Bits to run a small backup camera mounted onto rover? Is that something that you think a microbit could be done?
That's interesting. So with a microbit, I believe you probably can with a microbit. It depends on whether you're tethered to the microbit or not, I believe, for the data for a camera. But you can certainly run other sensors as well. So you can do things like ultrasonics to judge your distance and different things like that to be able to automate the movement of Rover Plus. So it's a great question. In the Raspberry Pi, you can definitely do it with a Raspberry Pi. Has a little more processing capability to be able to work with cameras to stream that data over Wi-Fi then.
Yeah, I think that's really kind of key to kind of highlight with the Raspberry Pi. Really, if you think it can be done with something, usually it's the Raspberry Pi is the answer, but that doesn't mean it's going to be easy. One of our engineers is really into first-person drone flying and has been able to take the cameras from his first-person drones and attach them to a Raspberry Pi, put it on top of rover, and then drive around rover with his first-person goggles on driving, which is a lot of fun.
Yeah.
Awesome. Let's see if there's any other ones. How many kids can use one robot? This is a really good just classroom implementation across all of our Sphero products, but I'm going to go ahead and let you just answer that one, Brad, from your experience.
Yeah, so I'd say 2 to 3 students is the ideal ratio per robot. You know, having more than that, you start to get students that are left out of the process and kind of check out from the activities that are going on. So 2 to 3 students per robot is ideal. You know, one way to kind of differentiate this for your students, kind of chunk up that data, is have each student take on a different process. So if they're using third-party hardware, like one student is building the circuit, right? Another student might be handling coding. You know, as you go through that kind of figuring out those different job duties, and it allows the students to then share their experience with the other students as well. So that documentation and presentation part of it really comes into play, because now you can teach even more content in that same amount of time. Great question.
That's awesome. Yeah, it looks like we got a lot of the answers taken care of, which is great. Hopefully, if there's any last ones that kind of come in, someone from our moderating can handle answering those really quick, because we have a giveaway to give away. So let's talk about who's going to be our Rover Plus giveaway winner. I'm going to pull up the attendee list here and do our giveaway. So let's get a little drum roll. I know that. So, and it is Juan Marquez, who's our winner. Juan, congratulations on a Rover Plus. We are actually going to have our marketing team member reach out to you, Juan, and we'll be able to coordinate how to get that Rover Plus to you so that you can get programming with Rover Plus and do some amazing things. We will be sending out PD certificates to all of the live attendees, so be on the lookout for that within the next week or so. If you have questions like about grants or about other things, you can reach out to education@support.com. We love seeing what kids are doing in the classroom. We love what teachers are doing. Please share and follow along with us at all our social channels that are listed there. So please take a look at that. Also a great place for inspiration for you as well. And last but not least, if you want to know when our next Sphero session webinar is, at the bottom of our website, there's a sign up link so that you can put your email in and know when the next webinar is going to be. We appreciate you all so much. All of you educators, you do amazing work. We appreciate the time and effort you put in to make sure our students have amazing learning and amazing activities to do in the classroom. We're glad to be a tool in your toolbox to be able to help you out. Thanks for joining us all today. Have a great rest of your day.